Hi, welcome to the fun probability problem solving sections. And today we're going to solve another very interesting problems here. And for this problem, I divided into two parts. Part 1 and part 2, and I'm going to do 2 videos because one video probably is too long. Okay, let's take a look at what is the problem about. Let's say let omega equal to 1, 2, 3, 4 till n. And suppose A and B are independent and equally likely to be any of the 2 to the nth power subset of omega. So the part 1 I want to show is if A is part of the subset of the B, then what is the probability? It's such a nice looking the probability, right? It's 3/4 to the nth power. Okay, then the part 2 is if A intersect B equal to the empty set. What is the probability for that? It's the same thing. It's 3/4 to the nth powers here. Wow. Okay, so this video, let's take a look at the part 1 first. All right, so now let's go to the whiteboards here. And so here's the whiteboard. And before we solve the problem, let's make sure we understand what is the problems here. And I'll give you an example, and then we're going to solve it. Okay, so let's take a look. And so let's give a small omega set. So omega is equal to the 1, 2, 3, 4. Okay, so that means for the omega set, so total we're going to have a 2 to the 4th 16 subset. Right, so what are those 16s here? The first one is going to be what is empty set. Empty set is a subset, right? Then we have a subset with only one element. It's 1, 2, 3, 4. All right, and then we also have the subset with 2 elements. So we have 1, 2, 1, 3, and we have 1, 4. Then we have 2, 3, 2, 4, and we have what? 3, 4. That's right. So 3, 4. Then we also have like a 3 elements subset. So will be 1, 2, 3, and 1, 2, 4, and we have 1, 3, 4, and we have 2, 3, 4, 2, 3, 4. Then the last we have is all of them. So it's 1, 2, 3, 4 is the subset of the 1, 2, 3, 4. So total, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so that means this is 16 subset. So let's say A and B, they are independent and equal likely to be any of this subset here. Okay, so let's see. So like in here, they said if the MB, okay, so let's say here, if the one of the subset is MB, will be 2 here. The number of the subset is 2, right? So we know the total number of the chance to get it will be 4/2 here, right? All right, so let's, okay, so now let's, for examples here, let's say the N2, NB equal to 2, let B, let's say, okay, I randomly choose this subset. So let B will be 1, 4. Of course, you can choose like 1, 4, 1, 3, 2, 3, 2, 4, 2, 3, 4, right? So total you have 6 of here. Okay, so let's take a look at the 1, 4. Okay, so for this first situation, if A is a subset of B, okay, so the What is that means here? So for subset of the B's here, we have this many situations here. Okay, so we said from, because it's a subset, right? So A could be only elements here. So we choose one element. Oh, maybe here instead of the one form, get confused with one element. So let's see here. So in this one, we're not going to get confused here. 3, 4. Okay. So that means you can choose one element. That one element, that means 3 or 4, right? So if you choose 3 or 4, then the A will be a subset of B's, right? So the A here could be, right? So A could be 3, A could be what? A could be 4, right? Okay. So now, how many chances I have here? So that means I have 2. You need to choose 1, correct? Okay, so now let's take a look. So also the same things here from the B here. This is 3, 4. So how many? From the 3, 4s here, I have to choose. I can choose 2 elements. So like in here, I have no choice. It's what? 3 and 4. So A, this subset is 3 and 4. Okay, so what is the chance? The chance is what? 2 choose 2. Okay, and then the last one here is, we said from the 3, 4, I choose 0 element. What's that mean? That means the A is equal to what? Empty set, right? So the A is equal to the empty set. What is the chance here? It's 2 to the 0. So did you see? It's 0, 1, 2, right? Okay, so if this is still not clear, so for this example, then I think we will be able to write out the information right away. So for example, if B is equal to the 2, 3, 4. Okay, so the 2, 3, 4. So total how many? So this is NB equal to what? NB equal to 3, right? So how many chance? 4 to the 2, or 4 to the 3. I'm sorry here. Okay, so now let's take a look at what type of the situation. So if A is a subset of the B, so the same things here. We will say here is, so if I said here, I will choose 0 element. So what is that? So A is what? Empty set, right? Okay, so the next ones here, I will say from this set, I will choose 1 element. So what is the A's here? A could be 2. This is set 2. A could be set 3. A could be set 4, right? So this ones here is how many chances? 3 take 0. This is 3 take 1. Okay, so now the next things here. So I will be able to say, how about I want to choose 2 elements. They still will be a subset, right? So then what could be the A? A could be what? 2, 3. A could be 2, 4. And what could be A? A could be 3, 4, right? So this one is 3 to the 2. Or the last chance here, I would say I'm going to choose 3 elements. That means A is the set as B. It's also is a subset. It's 2, 3, 4, right? So here is 3, choose 3. Okay, so think here, take a look here. From these 3 examples here, is always start with what? 0, 1, 2, 3. Depends MB, so MB here is 3. So it's from 3 to the 0, 3 to the 1, 3 to the 2, 3 to the 3. So like when here, the MB, from this ones here, MB equal to 2. So it's 2, 2, 2. Then here is the same thing here, 0, 1, 2. All right, so now we be able to, okay, so now, okay, let's take a look. Because of this, now let's try to write down the formulas here. Let's try to prove it here. Okay, so the first thing here, I can say the probability if the A is a subset of the B, all right? So if A is a subset of the B, so you can say it's a summation from the probability A is a subset of the B, given that the number of the elements in B equal to the I times the probability, the number of the elements of the B equal to I. Right? Now, what is my I? I is from 0 to n. Correct? That's just show from the previous one. So you can say B is equal to 2, B equal to 3, B equal to 4, B equal to 1, B equal to 0, right? Okay, so that's what is, oops. Okay, so that is what this formula about. Okay, so now let's take a look. Let's take a look at this one here. The first one, this is a P and B equal to I. So we know the P and B equal to I. So what is we say here? That means the total you have n, you take I. Right? So if you go back to here, that's what we put in here. That's why I said here NB, right? So your total is 4, you take a 2. Total is 3, you take a 4, take 3 here. All right. So this is NB. Then the total, how many situation? Total is to the 2n, right? So this probability, it is equal to the ni over 2n here. Okay. And now let's take a look this probability. Okay, this probability we just demoed in the previous one. This probability you can write as, like if you go back here, you can say it's equal to, when you equal to 2, is you add up 0, 1, 2. And equal to 3, you add up 0, 1, 2, 3. Right? Okay, so now when NB equal to I, so you say, okay, I can add up, right? From the I, you take a K elements. K is from the 0 to where? 0 to I, right? That's what we did here. So you add those up here, 0 to I. Then overall, over what? 2 to the n power here. Okay, so right, so this one's here, inside here, this probability is here, and this probability is here, right? Okay, so now let's write this. Okay, so this one is a summation. Okay, so this is a summation I from 0 to the n. And this one's here is 2n summation k equal to 0 to the I, ik. all right? Then times this one is 2n ni. Okay, now here, okay, let's take a look at this ones here. You say, whoa, what is this ones here? Okay, so for this ones here, I'm going to use the, so let's do a quick review here. I'm going to use the binomial expansions, right? Binomial expansion. So we know this famous formula for the binomial, if x plus y, all right? If x plus y to the nth power, what is this one going to tell you? This one is a summation going to be n to the k, all right? Then k from 0 to n will be x to the k and y to the, well, let's instead of k, let's don't want to confuse with this case here. Let's say here, n to the n, all right? So here, this is n to the n, so we don't confuse with the k here. So this is the n, so this is x to the n, y to the n minus n. This is the famous, the binomial expansion. Okay, so now for this ones here, right? So for this one, we have a summation k from 0 to ik. I can rewrite this one is a summation k 0 to ik. Then I can put this is as 1 to the k's power times 1 to the I minus k's power, because 1 to the any power stays once, right? So think about this. This one is the binomial expansion. So this is x, this is y here, right? So what is the answers by use the binomial expansion? So this one will be equal to x plus y. So it's 1 plus 1 to the how many? N's power. So for here is i's power. So this is 2i. Okay, correct? All right, so this is 2i's here. Okay, so now this one we simplify that. So this is a summation I from 0 to n. So this is 2n. And what is here? This is 2i. All right, so here, okay, so this one's here. This is 2n. And then, well, I can move this 2n to the front, so I don't kind of make it a little bit easier. So this is 2n. Then this one's here is n factorial, I factorial times n minus I factorial here. Okay, so these two, I can simplify that. Right? So these two, I can use the exponents definition to simplify it. So I can simplify, this is 2n, this is a summation I from 0 to n. So what is this? This is 2 to the n minus I to the 1. Wow, it seems like I got something here, right? So this is n factorial, I factorial, n minus I factorial. Okay, so in here, this one's here, I'm going to use the binomial expansion one more time. So how do I use the binomial expansion one more time? Okay, take a look here. So this is a summation I from 0 to n, right? So this is the, okay, so here, this is n factorial n minus 1, right? So this is the n to the I, all right? So it's n minus I, right? So n minus n's here, right? So the n minus n's here, right? Okay, so now I have this is 1 over 2 the n minus I. Then I need to have i's here, right? So I use the same trick. I times 1 to the what? The i's powers here. So what happens here? So this is my x, this is my y. All right. So now the whole this pink one I can rewrite it 1 x plus y 1 plus 1/2 to the what? To the nth power. That's right. Okay, so I still have this 1 of the 2n in front of it. Okay, let's take a look. So this is 1 over 2n times 1. So this is 3/2 the n, right? So now I can combine. So what is here? I can just say this is 4 to the 3 the nth power, right? Because this one you can change. This is 1/2 to the nth power, 3/2 to the nth, right? So by the exponents product rule, like the product of the two exponents, you can just kind of take the exponents out and then do the multiplication inside. So this is 3/4 is the n. Very, very beautiful proof, right? And also the result is very, very beautiful here. Hope you enjoy this. If you understand this, then the second part will be pretty easy. All right. Okay, so let's stop here. So we'll do the second video for the second part. Okay, bye.